Hello friends, today we will discuss ZX is not a principal ideal domain. Firstly, we will see what is ZX and what is principal ideal domain. Right, ZX is set in which all the polynomial of type 2x, 3x, 5x, 6x, right? So, but it is in this polynomial ring there is not 2 by 3 of x type polynomial, right? It is a rational numbers, so it is not as in ZX. Now what is principal ideal domain? Principal ideal domain is the integral domain in which all the ideals are principal. Now let firstly, since let I is equals to 2 comma x is generated by 2 and x, 2 comma x, it is a ideal, right? It is a principal ideal. We will let it 2 comma x, and 2 comma x generated by 2 and x. 2 is a even polynomial, and this is a even polynomial, right? Since 2 comma x generates only even polynomial, it is a even polynomial, it generates only even polynomial, so it is a proper ideal, right? But ZX contains all the ideals, even polynomial and odd polynomial, so it is said to be it is a proper ideal. Let 2 comma x is in ZX generates, firstly we will let this is it generates all the polynomials, right? If it generates all the polynomial, so we take 2 is in ZX is such that 2 is in ZX, right? 2 is not is in Z, 2 is in ZX, so 2 is write it up is an of px and qx, right? 2 is in ZX. ZX is a polynomial ring, so 2 behave like a polynomial, so 2 is written as 2 is equals to px into qx. So degree of px plus degree of qx, which will give degree of px plus degree of qx is equals to constant, because 2 is a constant, so degree of px and degree of qx gives constant. So px and qx must be a constant polynomial. If this gives a constant, so px and qx also it also must be a constant polynomial. If it must be a constant polynomial, so 2 is a prime, so it is in between plus minus 1 or plus minus 2, right? Now let px is equals to plus minus 1 and qx is equals to 2. It all is in ZX, right? So if we take px is equals to plus minus 1 and qx is equals to 2, this will give that it is not a proper ideal, as px is equals to plus minus 1. Plus minus 1 generates whole z, right? If we take 2 into 2, so it will become plus minus 2. If we take 3 into 3, it will become plus minus 3. All elements belongs with plus minus 1, so it is not a proper, it will not make a proper ideal, it will make whole ideal. So this contradicts the fact that we will take 2 comma x, it is a proper ideal, so this contradicts that fact. Now second choice is that if we take px is equals to plus minus 2 and qx is equals to 1, right? If we take qx is equals to 1, for this we do not generate all the elements, because first prime it is only plus minus 2, and plus minus 2 is generate only 2 type, plus minus 2 type, not plus minus 4 type, only this multiple of this 2, but it does not generate any all the elements of this ideal, so it is impossible. So ZX is a proper ideal, so ZX is not a principal ideal domain. How? Now second example is that qx is generated by 2 and x, then qx is a principal ideal domain. Now let us define how to 2 comma x is the principal ideal domain in qx, because in qx we will take 2 and x gives the whole ring 1. It gives 1 by taking, when take the multiple of this q elements is that 1 by 2 type, then it is 1, it will become 1, and this in x to make 0, multiply with 0, so this term is 0 and this term is become 1, so 1 generates whole ring, so this is a principal ideal in this qx. And this will give the other theorem is that for any field f, fx be a principal ideal domain, since for f there exists an inverse, fx be a principal ideal domain for any field f. Z is not a field. Z is not a field, right? But Q is a field. Q is a field. So for fx be a principal order element, f should be a field.